Yo, what's up guys? So today we're going to be doing something a little different than usual. We're going to be in Minecraft. And what I want to show you guys is my Minecraft computer. So this summer I got really interested in computers and wanted to learn how they work. And I figured that Minecraft would be a really great way to figure out how they work. So I learned how to make them in Minecraft. And I have made one now that I am almost done with, and am working on adding more functions with and stuff. Right now it's very simple, but I want to show you guys. So here is my computer. It's very simple. It has 16 bytes of instruction memory. It has 8 bytes of data memory, and then it has very simple 8-bit addition and subtraction right here. So now I want to talk about how it works. So here we have our instruction memory, and it's really simple. It's just if there's a redstone block there, it's a 1, and if there's not, it's a 0. And how it works is these are connected, so each step has 16 bits total, just 2 sides. And as it cycles through steps, it will unlock these pillars. So these pillars of redstone are all powered, and whenever it goes to the steps, it will unpower one, and then when you switch the step, it will power that one and then unpower this one. And whenever it's unpowered, it allows the signal to go through and be outputted, basically. Now these are all plugged into different areas here. This left side here is plugged into the input, so this is the number input. It's also connected to the display here and this display, which I'll explain what those are in a sec. And then the right side goes all the way down here, and down here this is for functions, and this is for memory slots. So depending on what the function is, this right side will be used differently. So of course, if it's a memorize function, it will go to here and it will be memorized. If it's a operations function, it will unlock the displays on both sides here, and it'll go to the displays. So how this works is whenever you input something, it actually memorizes it twice. So it memorizes it 2 sides. And so that way it actually has 2 outputs. So that way whenever I'm doing operations, it makes it very easy to output, because I can instantly get 2 numbers, whichever numbers I want, whichever memory slots I want to unlock and display. These are really simple decoders, and what a decoder is it basically just takes in a binary, a combination of ons and offs, and figures out which line it is. So 0 in, it's going to unpower this line. If I have a 1, it's going to unpower this line. If it's a 2, it's going to unpower this line, and so on and so forth. And it's same idea on the other side. Now all the way down here we have our memory up here, and it's really the same concept. It's just it's a decoder taking whichever memory slot I want and unlocking that specific memory slot. And down here it is another decoder, and this is for the function. So we have 1 is memorize, we have 2 is add, 3 is subtract, 4 is going to be multiply, and here we have 5, which is what I want to work on, which is a loop function. So I want it to be able to go back to a certain step, basically. So I could make loops. So then, at the end of my sequence, I could say jump to step, I don't know, 3, and it would just loop that. So that's really the basic components. The really main thing is just the wiring. So right here, this block here is whenever I power it, that's the execute function. So it either unlocks the memory core to be memorized, or it opens the displays. So that's really it. And it's all controlled by this lever over here. What this lever does is it's connected to the execute, it's connected to the instruction input, and it's connected to this step counter. So what this thing does is it basically just takes, it's a really simple adder, it just takes the previous step number, so maybe it was a 5, and it just adds 1 to it, so 6, and 7, and then 8, and 9, so it really just counts your steps. But what you can also do is you can also input a step into it, and that's where my loop function is going to come in, where I unlock the lines to this, so I can input into it, and I can pick whatever step I want. So it can go back to a step, or I guess theoretically it could skip a step, but that doesn't seem really it doesn't really seem efficient at all. It doesn't really make sense. but it can go back to functions, which is really what I'm looking for. So I can actually loop operations and steps. So whenever I turn this off, it will open up the instructions and basically output whatever instruction it is. And then when I turn it off, it will execute the function. So it will basically power that off, so there's no new instructions, and then it will execute. And then it will also just preparation for the next step. It will just add one to this whole step thing. And that's really it. One major thing I want to work on is, so I've made a processing unit. It's not really a computer, it's like a CPU, similar to this in the past. That did not have the jump function, and one issue with that is I spent too much time on the timing, so I made everything sync up, but the thing is that takes so long and it's so inconsistent that it just didn't work, and it was just not fun. So what I've been working on is relying on timing as little as possible so that it is as efficient as possible. So let's run some really simple functions here. So I spent way too long yapping about this, so I just wanted it to run a very simple program, and I was explaining what all of this meant, but I'll just sum it up. So it's a very simple program. It just says we're going to load a 1 into the memory, we're going to load a 2 into the memory, we're going to add them and save it, so 3, get a 3, we're going to save it, and then we're going to move the 3 to another memory slot. And how I had to move the 3 is what I explained for a while. how I moved the 3 is I just added the 3 to 0 and then moved it to a memory slot, because right now I don't have an operation or function to move one memory slot to another. So that's really it. Okay, so let's check this out. So how this is going to work is I got to make sure this is the memory, this is the step. So right now we're on step 0, so let's go. So as you can see, we have 1, we are memorizing it there to slot 1. Okay, perfect. So now what we're going to do is we're going to flick that off, so it should turn off, but then it also memorizes it to slot 1. And how I'm going to show you guys here is that repeater is on. That means that it's memorized and it's locked. So it's on and locked. So now we're on step 1. What is step 1? So we're taking 2, we are memorizing it to slot 2. So that's easy. And now we're on step 2, and we're going to take now, there we go, 3. So you guys may be wondering, okay, well, what was that I saw right there? Well, that was just the 8 bits. Remember I said the 8 bits are used for different things? Well, in this case, they are used for the display, but, and I usually lock this area here with just this line right here. Like, again, we have comparators, we're just locking them. But it takes a little time, so it's a little delayed, so you just see it flash through for a sec, but then it's all fine. And now it is displaying the output here, because again, remember, it cycles. If I can show you guys, we get our output here, and it just cycles all the way around back into here. And now we have down here, we're going to be adding, and we're putting it into slot 3, so perfect. And now what we're going to do is we're going to turn that off, so it should turn off. Good. And then we're going to open this up, and then we're going to put 3, give it a second, turned off, boom. So we have 3, we are adding it to 0 in this case, and we're putting it into slot 1. And now if I turn this off, it's kind of difficult to see here, but this repeater here, that's the 1 spot, so we have 1, 1, which is 3, in slot 1. This is slot 1, remember it starts at slot 0, so we have slot 1 is 1, 1, so which is 3, and we have slot 2, which is 0, 1, which is 2. So that worked as expected. So my overall goal so far is to program the Fibonacci sequence into my computer, and also get a good clock for it running, because I don't want to be there all the time flicking that lever. I want it to be automated. So in the next few days I'll probably post another video just showing how I made the Fibonacci sequence, and I'll also automate the input, so the step counting basically over there. I don't want to be flicking the lever the whole time. But for now, that's about it. And you know what, let me know if you guys want to see anything else I made in this world. I've made some pretty cool stuff. I made a game once, a really simple game. So let me know if you guys want to see that. But for now, that's about it. Peace.